Hello, hello. All right. So today we'll be going back to depth first search because yesterday when I looked at this problem, I didn't understand it. Even after looking at the solution, I didn't understand it. But today, um minding my own business, I had an epiphany and I realized, you know, that this problem is really not that bad. And so I realized that I could do it, and so I am here to do the problem. So yeah, with that being said, guess we'll start off by approaching this problem and seeing what we can do. So first, I guess we'll read the problem. Given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. Um, so basically, uh, you want to basically find the longest path of the binary tree. Um, and I guess the thing to really, look out for would be the length is represented by the number of edges. So you don't actually want to count the number of nodes. Um, if you were doing this problem coming from like grokking the coding interview, um, they, I believe their solution or like their question asks you based on the number of nodes. So instead of three, their solution would net you four. So you have to be very careful with those things. So this Leetcode question, it's represented by the number of edges instead. With that being said, we'll start our implementation of the solution. So for this solution, we will be using a helper, or not a helper, a class level variable. We'll call it diameter. We'll set it starting equal to 0. We will define the actual, like, the call to this later. We're gonna write our helper first, so we're gonna call it diameter helper. We gotta pass in self because it's part of this class, right? We're gonna pass in a node, which is an optional tree node, and it returns an int. So moving forward, what we need to do is, if not node, because we have to handle our uh, edge cases, we return 0 because there is no path, right? Um, there is no diameter for a null or none object. And so we're going to make recursive calls because for depth first search, that's what we do. We're going to make recursive calls to our helper function by passing in node.left, and then right height is equal to self.diameter helper node.right. I think that's pretty self-explanatory. We're just making recursive calls to our height function, or like not height, our diameter function. And so we're going to have a temp diameter. The reason why I call it temp diameter is because it's only going to last in the scope of this function. The only one we really care about is diameter up here. And I didn't want to define this as diameter as well. So I'll just call it temp diameter. And we're going to do left height plus right height. The reason why I only do left height plus right height without including 1 plus, typically if you count by the nodes, you would want to do 1 plus. But then if you notice, the number of edges is really just the nodes minus 1, right? So I can just ignore this plus 1 here, and that will give us the number of edges. And so temp diameter is now the number of edges between, like, the height of whatever subtree we're currently looking at. So like for this, it would end up just being 2, because you can go here. This would be 1. Actually, though, I'll explain it afterward because I guess it factors in with like our return uh, function. So basically, we calculated our temp diameter. Now we're going to set our diameter value here. So we're going to self that diameter because it is one part of the class, so we have to do self. We're going to take the max of self dot diameter because if we have a bigger value, we definitely want to keep that, or temp diameter. So whatever value is bigger, because we do want to find the length of the diameter of the tree, and that it will be the longest path between any two nodes, right? And so after that, we will have to give a return value so that we can do our addition in like calls higher up, aside from a not from a 0 return, right? So here we're going to return the max of left height or right height, but we need to add one here because like that's the number of nodes, right? And then so obviously our diameter, we can just ignore the one node that we're currently at because we want the number of edges. So that's what makes this question a little bit more confusing than it has to be. Um, because for our diameter here, we're dealing with the number of edges. Here, when we're returning out of this diameter helper, we're dealing with the number of nodes that we see. So that's what makes it a little bit confusing. Um, but yeah, with that, this works. Um, so basically, like I said, if we're looking at the subtree 245 or like 425 or however you want to call it, um, so we call diameter helper on this 2, and then so it is not null or none, so we don't return 0, right? Left height, we'll call it on 4. Right height, we'll call it on 5. So we'll do 4, and then it's the same thing for 5, right? We'll go to 4. It's not null, so you don't return 0. You call these, but then both of those are null. So it's 0, 0. Temp diameter is 0 plus 0, which is 0. So it's self dot diameter. You would probably keep whatever diameter you have unless it's already 0. Either way, it'll still stay at 0. Then you return the max of those two. So, but they're both 0 and plus 1, so that there is one node attached to 2, right? And same thing for 5. So now left height and right height are both equal to 1 going into 2, right? And then now the temp diameter is 1 plus 1, which is 2, which is correct because we have one node. We have 2 nodes connected to it, but like that's just 2 edges, and like it would have been like 3 nodes, right? So if you wanted to calculate for the nodes, you just do 1 plus that. But we're not calculating for nodes, we're calculating for the edges, so we just keep it at that. Self dot diameter equals self dot the max of that, or temp diameter, and then you return the max of left or right, which is just 1, and you do plus 1 for 2. So basically, because they're the same, right? Regardless, this could be the longest path, or 5213, like they say here, or 4213 could be the longest path, because it doesn't matter if it's left or right, it's still going to be the longest path, but by the number of edges, right? Um, so yeah, and then you just return and you go up, and then you'll be calculating this. So here you just need to make sure you call the helper, you pass in root, and you return self dot diameter. Yeah, so you just want to make the call to the diameter helper, and then since this will set the value in self dot diameter, we don't need to do any like return here, or like self dot diameter is equal to that. No, we don't need to do that because we set it all within this. We set the self dot diameter value within the function, so we just return it here, and we are good to go. Yeah, so let's just run the solution, and then it says, oh, we passed the problem. Well, all right. Yeah, so that is how to do the what is this problem again? Diameter of binary tree question on Leetcode. with that being said, thank you for watching, and I guess I'll see you around.